Hello and welcome to this Reigate Core Maths video on volumes of revolution. And in this video we'll be looking at a slightly harder example than the ones we've covered already. So we're looking at this question here. We've got the area enclosed by a curve y equals x squared minus 3 and the line y equals minus 2x. And we're going to rotate that about the x-axis. So first thing to do is just quickly sketch what's going on. So we've got a curve y equals x squared minus 3. That's going to look something like this. And we've got the line y equals minus 2x. So that's going to be going down here. And this area here is rotated about the x-axis, about the x-axis here. So we need to find out this point of intersection here and that point of intersection there with the axis. So a slightly larger diagram is going to help. So we've got the line y equals minus 2x there, and we've got the curve here. This point here is going to be root 3. That's 0, so we need that point of intersection there. So we're going to solve x squared minus 3 is equal to minus 2x. Rearranging that, we get x squared plus 2x minus 3 equals 0. Could use your calculator, or you can just factorize. That's going to be x plus 3, x minus 1 equals 0. So x is minus 3. Which corresponds to the intersection up here, not interested in that one, and x equals 1. So this point here is when x equals 1, this coordinate here. So what we now need to think about is what's the volume of revolution. It's going to be made up of two parts. We're going to have B here and C. This is going to rotate around the x-axis. This will form a cone. This here will form a sort of segment shaped piece. So let's look at what the volume is going to be. Remember that the formula for a volume of revolution about the x-axis is pi y squared, the integral of y squared dx between the relevant limits. So let's find the volume of section B, which we could have done using the formula of a cone, the volume of a cone, or we can do it by integration. So working through integration, our limits are 1 and 0. We've got y, which is minus 2x, squared, all of that squared. Use the brackets so you don't make a slip here. That's going to be pi times the integral of 4x squared dx between 1 and 0. So integrating that, we get 4/3 x cubed, let's put the pi in, between 1 and 0. Substituting in there, that's going to give me 4/3 pi minus 0. So the answer to that first section is 4/3 pi. The volume of section C is going to be pi, then the integral of y squared. Now y squared is x squared minus 3 all squared dx, and we're going to integrate that between root 3 and 1. So those are the two limits for the section C. So that's going to be the integral, pi times the integral of, squaring out these brackets, we're going to get x to the 4th minus 6x squared plus 9 dx, root 3 and 1, the limits there. And then integrating this term by term, we're going to get x to the 5 over 5 minus x cubed with a 2 in front of it plus 9x between, so that's evaluating that between the limits of root 3 and 1. Just moving this up slightly. So this is equal to, we're going to put root 3 in here and 1 in there. So it's going to be pi times, I'm going to do some great big brackets. We've got root 3 to the power 5 over 5 minus 2 root 3 cubed plus 9 root 3. So that's the first limit substituted in, minus substituting in 1 minus 1/5 minus 2 plus 9. Finish that bracket there, another bracket. And when you work that out on your calculator, you will get pi multiplied by 24 root 3 over 5 minus 36 over 5. If I was just working through this as part of an exercise, I might do this step on my calculator without writing it all out. But if I was doing it in an exam, there will be a mark for showing you understand how to put limits into an integration like this. So if I was doing it in the exam, I think I would write out that working just to make sure I got that method mark. Now, we haven't quite finished because we've got the volume of B and the volume of C, but we're asked for the total volume, so we need to add those two together. So the total volume is going to be this answer here, 4/3 pi, plus this answer here. And when you work that out, you get 24 root 3 over 5 multiplied by pi minus 88 pi over 15. And that's the final answer to this question in an exact form, exact value. So you need to draw a diagram to make sure you're clear on which sections of the shape are made from which sections of the graphs, and then just work carefully through to get a correct final answer.